Imagine a world. This world is different from ours. In this world, our view of the cosmos is very limited. We can only see what our naked eyes show us. This was the reality for almost all of human history. The stars were just tiny, twinkling lights in the dark sky. The planets were mysterious wanderers. Their true nature remained hidden from us. Without the telescope, the universe stays a deep mystery. It is like a grand, beautiful book, but we cannot read most of its pages. Our ancestors looked up at the sky often. They saw patterns in the stars. They created wonderful stories about them, but the deeper truths of the cosmos were hidden. The true scale, the amazing complexity, the sheer wonder of it all remained beyond our reach. The telescope was much more than just a simple tool. It was the key to unlocking the secrets of the universe. The year 1608 was a truly pivotal moment in time. In the Netherlands, a new invention was quietly emerging. Hans Lippershey was a humble eyeglass maker. He applied for a patent for his new device. This device could make distant objects appear much closer. He called it a kijker, which simply means looker in Dutch. This was the actual birth of the telescope. It was a simple tube. It contained carefully shaped pieces of glass called lenses, yet its potential power was absolutely immense. At first, it was not aimed at the distant stars. People thought more about its military uses. For example, seeing enemy ships from far away, or it could be used for surveying land more accurately. The news of this amazing invention spread quickly. Within just 1 year, Galileo Galilei in Italy heard about it. He pointed his new, more powerful telescope towards the heavens. Nicholas Copernicus proposed his sun-centered model many decades earlier. His groundbreaking book, De Revolutionibus Orbium Coelestium, was published in 1543. It bravely suggested that the Earth was not the center of everything. Instead, Copernicus argued, the Earth and the other planets orbited the Sun. This was a truly radical idea for its time. It challenged centuries of deeply ingrained belief and tradition. However, Copernicus's model lacked definitive, observable proof. Galileo Galilei changed all of that with his observations. Using his improved telescope, he saw Jupiter's 4 largest moons. They clearly orbited Jupiter, not the Earth. This observation showed that not everything in the heavens revolved around our planet. He also saw the phases of Venus. These phases were just like our moon's phases. This could only happen if Venus orbited the Sun, not the Earth. Without a telescope, Galileo would have had no such compelling evidence. The telescope did not just help confirm the heliocentric model. It opened up an entire universe of new, breathtaking details. It revealed things no human eye had ever witnessed before. Imagine the sheer wonder Galileo must have felt, or the awe experienced by those astronomers who followed him. They were truly seeing the cosmos for the very first time in its intricate, detailed glory. Saturn, for instance, presented a curious sight. To the naked eye, it is just a bright star-like point of light, but through early rudimentary telescopes, it looked distinctly odd. Galileo himself was initially confused by what he described as its ears or handles. Later, Christian Huygens, using better and more powerful telescopes, correctly identified them as a magnificent system of rings. Without telescopes, Saturn would remain just another wandering planet. Its stunning ring system, one of the solar system's most beautiful jewels, would be completely unknown to us. And what about the Milky Way, that familiar band across our night sky? To our unaided eyes, it appears as a faint, hazy, ethereal band. But then Galileo pointed his simple telescope towards this celestial river. Section 5. The Slow Dawn of Astrophysics, a Universe Unmeasured. Astrophysics is a fascinating branch of astronomy. It deals with the physical nature of the universe. It studies the properties of celestial objects, not just their positions or motions. It asks profound questions like, what are stars made of? How do they generate their immense light and heat? How do vast galaxies form and evolve over billions of years? The telescope was the very first essential tool for this entire field of scientific inquiry. Early telescopes allowed astronomers to see crucial details. They observed sunspots moving across the face of the sun. They mapped the craters, mountains, and valleys on the moon. They even noted the different colors of various stars. These new observations sparked a wave of new questions. These were questions about the physical nature of these celestial objects. They were clearly not just perfect, unchanging points of light in the heavens. They were actual worlds. They were dynamic and changing systems. Later, combining telescopes with other ingenious instruments, like spectroscopes, completely revolutionized astrophysics. A spectroscope splits light into its component colors like a rainbow. Section 6, the lenscrafters' standstill, optical innovations stifled. The invention of the telescope spurred a great deal of innovation in the craft of lens making. Early telescope lenses were far from perfect. They suffered from various optical problems called aberrations. These aberrations distorted colors and made images blurry around the edges. The intense desire for clearer, more powerful views of the heavens drove opticians to relentlessly improve their craft. They experimented with different types of glass. They tried various curvatures and combinations for the lenses. This significant push for better astronomical lenses had a beneficial ripple effect. The new skills and advanced techniques developed by lens makers were transferable. They greatly benefited the development of other optical instruments as well. Think about the microscope, for example. While simple magnifying glasses had existed for some time, the development of compound microscopes, which also use multiple lenses, accelerated alongside telescope technology. Better lenses meant clearer views of the microscopic world, opening up new frontiers in biology and medicine. Section 7. Echoes in Thought. A slower shift in understanding. The incredible discoveries made with the early telescopes were not just isolated scientific facts, they carried profound philosophical implications. They fundamentally challenged humanity's long-held view of itself and its place in the vast cosmos. For many millennia, we humans generally believed we were at the very center of everything. The universe, we thought, was created especially for us. The Earth was considered special, unique, and unmoving. The telescope began to paint a dramatically different picture of reality. Earth was revealed to be just one planet among several others orbiting the Sun. The Sun itself was understood to be a star, and there were countless other stars, perhaps with their own planets. The universe was vastly larger and far more complex than anyone had previously imagined. This was a deeply humbling realization for humankind. It forced a significant re-evaluation of our cosmic significance. This intellectual shift is often called the Copernican revolution, but the telescope provided the crucial, undeniable visual evidence. Section 8. Challenging the heavens, faith, reason, and a missing tool. In the 17th century, religious dogma was very deeply intertwined with the general understanding of the natural world. The geocentric model, which placed a stationary Earth at the center of the universe, was not just a scientific theory, it was often strongly backed by powerful religious authorities and interpretations of Scripture. The heavens themselves were widely seen as perfect, unchanging, and divinely ordered in a very specific, hierarchical way. This view had persisted for centuries. Galileo's telescopic observations directly and dramatically challenged these long-held views. Moons orbiting Jupiter. That implied other centers of motion, mountains and craters on the supposedly perfect moon, sunspots that appeared, moved, and then disappeared on the sun. These observations strongly suggested that the heavens were not as perfect or as Earth-focused as previously believed. This inevitably led to conflict. Galileo's famous trial by the Roman Inquisition is a prime example of this clash between new scientific evidence and established religious doctrine. Section 9. The Inevitable Eye, Another Dawn for the Telescope. If Hans Lippershey had not invented the telescope in 1608, would it have remained uninvented forever? The answer is almost certainly no. The basic components required, specifically lenses, were already known and widely available. Spectacles or eyeglasses had been around since the late 13th century in Europe. The fundamental principle of combining two lenses to magnify distant objects was, in hindsight, an idea waiting to be discovered by someone. Several individuals were actively working with lenses and optics around that time. Lippershey himself had competitors such as Jacob Metius, who also applied for a patent for a similar device shortly after him in the Netherlands. Even earlier, There are accounts of people like Leonard Digges in England who described devices that could magnify distant objects, though their exact nature is debated. The intellectual climate was ripe for such an invention. The technology of lens grinding was steadily advancing. It seems highly likely that someone else would have eventually stumbled upon the right combination. But the crucial question is when this would have happened. Perhaps it would have been just a few years later, perhaps a decade or two, or even longer. It is very hard to say with any precision.